Good evening. Well, we've seen the last of summer, such as it was, and we're now into autumn. And that means we've seen the last of the main summer stars. They're still there, but they're not so good as they were. In their place, we have the constellations of autumn, which are not so brilliant, but are full of interest. And this evening, I want to concentrate upon two of them, Pegasus, the flying horse, and Andromeda, the princess. Pegasus first, it's easy to recognise, high up in the north, and its four main stars make up a square, and Andromeda leads away from the square in a line. And the stars on the square are not all alike. Bottom right, Markab, magnitude 2.5, bluish white. Bottom left, Alganib, magnitude 3, also bluish white. And then top right, Skeet or Beta Pegasi, which is orange. It's a giant star, about 9,000 times more luminous than the Sun, and 200 light years away. And it is slightly variable, sometimes slightly brighter than Markab, sometimes slightly fainter. And finally, top left, Alpheratz, magnitude 2. And there's a rather minor mystery here. Obviously, it belongs to the Pegasus pattern, but for some reason I've never been able to follow. The International Astronomical Union has taken it out of Pegasus and given it a free transfer into Andromeda. And Andromeda itself has no definite pattern. It leads away from the square. So Delta Pegasi became Alpha Andromedae. Well, of course, these two constellations, Pegasus and Andromeda, there are many legends attached to them. So let's go now down to the beach where Paul Abel is ready to tell us about their mythology.
Many different cultures from around the world looked at the autumn sky and put their own myths and legends there. The most familiar story is Greek. In classical drawings, Andromeda is in much distress, and so she should be. The poor virgin princess has been sacrificed by her parents, chained to the rocks, awaiting a ravaging sea monster. The line of stars which points to the Andromeda galaxy make up her waist, and the star Alpheratz her mouth. In my drawing of Andromeda, she is mournfully awaiting her rescuer, the noble and brave Perseus. Well, we've been looking at the myths of Andromeda. Let's move over now to Pegasus. And the creation of Pegasus itself involves that most terrible, most feared monster, the Gorgon Medusa. It was said that Medusa stood enormously tall and her hair was a writhing sea of serpents, and a single glance at her eyes could turn a man to stone. Now, Perseus, the great warrior, was not fearful of her at all, and by using his polished shield he could see where she was, and in one go decapitated the monster. And from her body sprang Pegasus, the beautiful winged white horse, who then flew away to Mount Helicon and was used by Zeus, king of the gods, on many missions, and eventually, as a reward for all his work, placed Pegasus in the sky. Moving on from Greek mythology, we come to the Chinese, and I think it's fair to say the Chinese were some of the most creative constellation makers on the planet. For them, the region represents not a flying horse, but one of the four symbols. Each symbol represents a direction and a season, and the Pegasus region represented the great tortoise of the north and the oncoming of winter. In constellation charts at the time, you'll see a black tortoise with a serpent coiled around it. For the simple reason they believed that both the tortoise and the serpent created the Earth. The Chinese may have been the most imaginative, but when we see the four stars of the square, it is the Greek horse Pegasus which springs to mind. But in the autumn night sky, you'll find he's upside down, on his back. With some of his astronomical delights, Pete Lawrence with Tom Kerrs.
So, Tom, you've travelled down from London.
I have.
Now, you've got quite a lot of light pollution in London, of course, so I should imagine the Square of Pegasus is quite a tricky thing to pick out. But you can actually use it as a test for sky clarity.
That's right. So inside the Square of Pegasus there are stars. A little bit difficult to see when you step out, but as you get adjusted to the dark, you're able to see a few and determine what the sky is like by the number of stars that you can see.
Okay.
So in London, where I am...
How many can you see there?
We can see precisely 0 stars in the Square of Pegasus. So our skies are not very good, but you would fare slightly better here in Selsey.
Well, I think the average in Selsey is probably about 7, between 4 and 7 stars that you can see inside the square. So that's not bad, really. If you're in a really good site with no light pollution around you at all, very dark, clear skies, do you know you can actually see up to about 30?
30.
Well, that's amazing. Well, the square is up there at the moment.
Okay.
Because if you look at it on a chart, it doesn't actually look that impressive, does it?
It looks a bit smaller. That's what I find. When it's projected on a chart, it looks like it's a small, compact square. But on the sky, it's actually a lot bigger and sparser and not quite as bright.
It is a very sort of sparse area, isn't it? And the way to sort of describe the size of it is to use your fist and hold it up at arm's length, and a side of the square is about 1.5 times the width of your fist.
That's about 15 degrees.
That's right.
Because your fist is about 10 degrees when you hold it up at arm's length.
And the square represents the torso of the flying horse.
It does.
And from the UK, he's quite difficult to pick out because he's upside down.
Exactly, and he's sort of flying out of Andromeda's head with no hind legs at all, so a slightly unusual.
It is an unusual thing, but his head is picked out by a nice triangle of stars to the lower right of the main square.
Quite right.
Now, the star right at the extreme right of that is called Enif. And if we come back and go down a bit, so we come back to the left and go down a bit, then we come to a star which marks the top of the horse's head, remembering he's upside down.
Exactly.
And that's called Baham, or
Baham.
Baham, if you like. If you go from Baham through Enif and you extend the line by half as much again, you come to a rather amazing object, which you describe as looking like the carrot.
Not literally, it doesn't look like a carrot.
Okay.
It's in front of the horse's nose. So if we imagine in front of Pegasus's nose, which is Enif, there is an object there which is very tantalising, and that is one of the most spectacular globular clusters on the whole sky, M15 or Messier 15.
And that is a real beauty.
It's actually one of the oldest and densest known as well.
Right, OK. A globular cluster, of course, is a vast collection of stars which are all bound together gravitationally. And in this case, there's about 100,000 stars, all compressed into quite a small part of space.
Yeah, it's no more than 200 light years wide.
OK.
And we know that it must be, therefore, over 30,000 light years away. That's outside of the galaxy's disk.
Because all the globular clusters we see are in a halo around the core of our galaxy.
Exactly.
Now, M15 isn't actually that difficult to find, or see, is it?
No, you can see it with the unaided eye if you have exceptionally good skies. It's very easy to see in binoculars because it looks distinctly non-stellar.
Yeah.
It doesn't look like a star, it's a fuzzy blob, and if you use a small telescope, that's even more apparent. But with a large telescope, well,
it's an amazing sight, it is.
Start to see the individual stars.
It always reminds me of a glowing spider's nest. You know, you get that sort of collection of web in the centre of it. That's what they always remind me of, globular
clusters. That's a very
clusters.
terrifying image, Pete.
Pegasus will be forever immortalised for being home to 51 Pegasi, the first star found to have an exoplanet in orbit around it. Earlier on, Italian astronomer Dr Giovanna Tinetti came to Selsey to see Patrick and Chris North. She studies these worlds around other stars, and so far, most of them are gas giants. We know of more than 650 exoplanets out there, but 51 Peg B will always be the first.
What's it like?
What we know about the sort of class of planets like 51 Peg is that they are presumably very similar to our own Jupiter, so gas giant planet, mainly made of hydrogen. But these hot Jupiters are orbiting very, very close to the star, like 51 Peg B. Sometimes they have a few days or even less than 1 day annual period, and it means they can reach temperature that are over maybe the 1,000 or 2,000 degrees Celsius. So clearly are a bit like Hells.
Not so long ago, we had no definite proof of any planets outside our solar system.
It's astonishing how quickly this field is moving. I mean, 16 years ago we found the first, and now we know hundreds of these things. And that's because of all the different experiments and satellites and telescopes we've got detecting them. I mean, we've got telescopes looking for the tiny wobble of the star as the planets go around them. So, I mean, our own solar system does that. The solar system doesn't rotate around the sun, it rotates around the centre of mass of the solar system, which is roughly near the edge of the sun. So if you were to look at the sun from afar, you would see it wobbling, mainly because of Jupiter.
Yeah.
And we see that in these other solar systems, and that's the main way of detecting these planets.
Do you think there are many planets in our galaxy that are similar to the Earth?
Well, I believe so. I believe so because the statistics is telling us that this rocky type of planet seems to be very common.
So, if you had to place a bet, how long would you say it'll be before we find an Earth-like planet?
Well, you know, given the pace of discovery we're seeing with Kepler and radio velocity, Doppler sort of measurement from the ground, I would say 1 year time. 1 year? Yeah.
Wow.
Well, we are so close.
Yeah.
Even so, I might see it then. Good. Thank you both very much, and delighted to see you going back on the programme. Come back soon. Thank you very much indeed. What about the stars in Andromeda? I say the main ones lead off in a line from the Square of Pegasus, beginning, of course, with Alpheratz. The second bright star, about the same bright brilliancy, is Beta Andromedae, or Malach, which is definitely orange. And the third is Gamma, or Almach, which telescopically is a rather lovely double star. But of course, the real glory here lies in the great spiral M31, the nearest really big spiral to our own. You can just see it with the naked eye, use Malach as a guide. Telescopically, well, it's placed at a bad angle to us, but you can see it really is something very unusual indeed. Over now to Pete and Paul.
So, Paul, M31, the Andromeda Galaxy, this is a real showpiece object in the night sky, in the constellation of Andromeda.
Yeah, it's a wonderful thing. And do you know, Pete, for the first time ever, when we were in County Wicklow in Ireland a couple of weeks ago, I saw it with the naked eye. It was really, really dark sky. I really couldn't believe it. You can see it with the naked eye. It's so impressive.
It is. Well, I see it quite frequently down here because
you're all spoilt.
I'm spoilt because I haven't got much light pollution. If you're in a city with lots of light pollution, it does actually cut out M31.
It does, yes, it does.
OK, well, I suppose what we'd better start with is how to locate M31.
Quite an easy one to find, isn't it?
Well, the easiest way I do it is by taking the top of the Great Square of Pegasus, the two stars at the top of the Great Square of Pegasus, and extending the one from the top right through the top left for the same distance on again, but bending up a bit until you come to another star which is about the same brightness.
Wow.
And that's Beta Andromedae.
Yeah.
And then you do a right angle turn, you go up until you see one which is slightly fainter, which is Mu Andromedae. Keep going a little bit further, there's Nu Andromedae, and right next to that, that's the Andromeda Galaxy. This is a galaxy of several 100 billion stars.
And quite a bit larger than our own. They're very similar.
Now, I'm glad you mentioned that both the Milky Way galaxy and M31 are of similar size, because I have a demonstration
I thought you
prepared.
meant some of the cheap Pete Lawrence demonstration. Oh, OK, this is good.
So who do you want to be? Do you want to be?
I'm going to be Andromeda.
OK, you're the Andromeda
I'll
Galaxy.
be the Andromeda
okay.
Galaxy,
So
yeah.
from the Milky Way galaxy, which is where I am here, you need to be tilted by about 13 to 15 degrees.
Is that enough?
That's a bit too much, bit flatter than that, actually.
Okay.
There we go, like that.
All right, OK, that's...
No, I need to be tilted to you by about 60 degrees, so
Right.
about like that.
OK.
And to create a scale model, we have to be about 3 metres apart. We can put them back over here. Now, that represents more or less the scale of what we're talking about here.
And that you could see that distance, that enormous cosmological distance with the naked eye, is quite fantastic.
It's amazing. It's about 2.5 million light years away.
Absolutely. Of course, over time, these two galaxies are coming
heading
together.
towards each other. If we simulate a 3 to 4 billion year time period, they will come together. Now, that's could be quite a terrifying thought, of course, but of course the huge distances between all the stars means that there probably won't be any collisions at all.
But it will be quite a spectacular view.
Probably won't be around when that happens.
I bet you will be, and I bet it'll be cloudy.
OK, well, now if we look at M31, you can see the core, but you can also pick out two other fuzzy patches either side of it. Now, those are satellite galaxies of M31.
They are gravitationally connected to...
They are indeed. They actually go around, they orbit mutually around M31. But in total, there are about 19 satellite galaxies to M31, which is an awful lot.
There really is remarkable. Just goes to show the enormous gravitational power of the thing. It's an enormous thing.
It's just an amazing object.
The Andromeda Galaxy is lovely to look at through binoculars, but there are some treats in Pegasus too. Why not try NGC 7331, a spiral galaxy not unlike our own. Or if you really fancy a challenge, have a go at Stephan's quintet, which has 5 galaxies. In the infrared, the Spitzer Space Telescope makes it look like a honeybee with a nice smile.
So much for the autumn constellations, but we have one brilliant planet there too, Jupiter. Look at it through your telescope, you see its belts, its moons, and its changing surface. It's the subject of our yearly competition to select the astrophotographer of the year, and the winner actually lives in Selsey, and Paul Abel went to see him.
Well, I'm here in Selsey to meet a rather famous astronomer. Not Patrick Moore, but Damian Peach, the celebrated lunar and planetary photographer. Damian's high-resolution images of the moon and planets, most of them taken here from his garden, show that you can take extraordinary pictures from a very ordinary setting.
Damian moved to Selsey just a few years ago for the clear skies. What with Patrick and Peter around the corner, Selsey has become a bit of an astronomical hotspot. His winning shot is of Jupiter and its 2 moons, Ganymede and Io. You can actually see surface detail on the moons. Quite amazing.
Hello, Damian.
Hi, Paul.
How are you doing?
Yes, I'm good, thanks.
Very impressive setup you've got here.
Thank you.
Congratulations on winning Astrophotographer of the Year award.
Thank
You must
you.
be very proud. That's
Yeah, absolutely.
phenomenal picture of Jupiter, but we should tell everybody, shouldn't we? You didn't take it here, did you?
Sadly not, no. I wish I could say I did, but no, it was taken from the Caribbean island of Barbados.
Yes, you got some good seeing, didn't you?
Yes, it's a great location for it.
And how did you come to get into astronomy, in particular into planetary astronomy?
I've always had a real fascination with the planets, I think because they're dynamic objects.
They change overnight.
Absolutely,
they're
changing, they're colourful, you can see so much on them, and that's really what really attracted me to it.
I would imagine Jupiter would be a good beginner's target, would it?
It's a fantastic target. Even with a pair of binoculars, you can see a small disk and the 4 bright moons either side. Perhaps aside from the moon, it's one of the best objects that a beginner could look at.
What about the moons themselves? Because, I mean, I remember a time when it was thought the moons of Jupiter were dead, cold, inanimate objects.
Yeah.
And now we know that they're, you know, some of the most exciting objects in the solar system, and that you can get detail on them now. I think that's just remarkable.
Yeah, as camera technology has developed from film to CCD, and now we have high-speed CCD cameras, it's allowed us to really exploit the resolving power of telescopes, and it's really allowed us to kind of start recording detail on the moons, quite regularly.
And the black magic that you invoke.
Well, yeah, so always a bit of that sprinkled on it, absolutely. And
of course, Damian, Jupiter is at opposition next month.
Now is really the kind of best time to look at Jupiter, because obviously with the planets at opposition, meaning it is actually, opposite the sun in the sky, so
visible all night.
Visible all night. Step out on a clear night in October around 10 o'clock. You would not fail to notice it is literally the brightest star-like object in the sky.
And of course, opposition, a good time to start imaging or drawing, or any time that you want to make a serious start on the planet, because, as you say, it's visible all night and at its closest. So
yeah, that's right.
Let's hope that many people follow in your footsteps, Damian. Quite a few also stick with the drawings. Damian, thank you very much.
Paul.
You can see the rest of the winners by finding a link via our website, bbc.co.uk/Sky at Night. Here you will also find our newsletter, number 123, with Patrick and Pete's advice on what to look out for over the next few months. Our Flickr site is also doing well. We have 2,000 members with over 10,000 astronomical images for you to look at. Here is a recent posting from John Kemp with his Aurora over Whitstable.
Well, congratulations to all those who take part. Next month, when I come back, I'll be talking about Mars and the probe Curiosity, which is going there. Until then,